have studied about the Ohm's law. We know that Ohm's law is V equals to IR, and the Ohm's law can be expressed in the vector form. Though the potential is a scalar quantity, current is a scalar quantity, and the R is the resistance is a scalar quantity. So I am just revising it once more. What is the relationship between E and V? E equals to minus dV by dr, so V by L. So E equals to V by L, therefore V equals to EL, where E is the electric field, L is the length of the distance we are taking, I, and the current density J equals to I by A, and E is the V by L, right? We have used this formula. So what is the value of I? I will be JA, and what is R? R is rho L by A. So if we take the electric field E, this will be the vector form. So what is the relationship? L will cancel out, A will cancel out. So rho equals to, or J equals to E by rho. So therefore J will be sigma E. So this is the vector form we know about the Ohm's law. Now there is another term known as mobility. Mobility, what is mobility? Is denoted by mu. The mu is always, it is a ratio of drift velocity and the electric field applied. Now the mobility, what will be the SI unit? The SI unit will be meter per second divided by volt per meter, no? Volt per meter. So what will be the answer? Meter square divided by volt second. So this is the unit for mobility. Now the mobility term generally we use in the semiconductor. So there we have electrons and the holes as the charge carriers. So there the mobility of the electron will be mu e and the mobility of the holes will be mu h. So there we will find out that the drift velocity of the electron divided by the electric field applied, the drift velocity of the holes divided by the electric field applied. So in the semiconductors, you will find that the mobility of electron is higher than the mobility of holes. So sometimes you will find, though the electric field applied is the same, each and everything, but the mobility determines the factor. So we will learn that the mobility of the electron is higher than the holes, and hence we prefer, in the semiconductor topic, we prefer the n-type semiconductors, that is those who are having electrons, and we don't prefer the holes, the positive type p-type semiconductor, because they have the holes as majority charge carriers and their mobility is less. So electron have the higher mobility than the holes. So sometimes the mobility also determines the amount of current flowing in the electrical circuit. Okay.